No, servus all. Thank you all for having me here, and thank you for you as attendees because you are making your time to join this great event, and you are giving me basically 1 hour or 45 minutes of your life, and that's pretty huge because I don't know how many are you in the rooms, but it's pretty impressive. Today, we'll talk about infrastructure as code. It's not something new. The story started a long, long time ago. And when you get older, like Florin, you will realize that these kind of things used to be done also on-prem or on other system in different ways. What we have now, we have the tools. The tools that enable us to do the right thing from the beginning, that can test and correct us when we do something wrong. Now, one question for you. How many of you are using cloud? Raise your hand, don't be shy. How many of you are building cloud infrastructure? Okay, not so many, because the rest of you, I hope that you are developers. And how many of you are using infrastructure as code? ARM, Terraform, AWS, CloudFormation, and so on. Yeah, there are a lot of options here. And the biggest challenge is not to decide what kind of tool you need to use. The biggest challenge is to identify exactly what you are building and how you ensure that the thing that you are building will work as expected. So the story time, because people are saying that we love stories. At least me, I'm listening a lot ETB radio, and they have a lot of stories, great stories. This story that I would like to share with you happened around, I think, around 2015, 2016, so a long, long time ago. I used to have a team, a great team, an amazing team. We were working on a solution for Microsoft Azure. On top of Microsoft Azure, it was pretty large. We are at the beginning on what we understand through landing zone, how you are building infrastructure as code, and so on. But we were struggling. We were struggling because the environments were pretty complex, and the team was not able to replicate the environment from one day to another, from the portal, from the PowerShell, and so on. During that times, it was the beginnings of ARM templates. We already used to have PowerShell and something like Azure CLI, but we were struggling. And how we managed that during that times was with nuke scripts. Do you know what is a nuke script? It's like a bomb. The rule was every Friday at 10 p.m., the environment will be fully deleted. So no storage, no VM, no computation, nothing. It was just blank. What was the purpose? Was to ensure that Monday morning we have the tools that can recreate the same environment, and when the team is coming back to work, they have exactly the environment that they need to be able to do their job. First 1 month, they hated me. After a while, things started to go pretty nice, but it was more try and error during that time because we didn't have the ways, the knowledge to be able to build. Now, it is a different story. If you are just Google it for how to build a landing zone or the landing zone basic script, you will find a lot of information. Another challenge, it is a fragile environment. Even with ARM, even with Terraform, even with AWS Cloud Formation, how many of you happened that you have an environment, everything works as expected, and after 1 or 2 days, or when you release something in a specific environment, let's say in the pre-production environment, things doesn't work as expected. And after a few hours or days, you realize, oh, damn it. I had a feature that was not active or configured in the right way. Why this is happening? Because even nowadays, not all the configurations can be done through Terraform, through ARM, to CloudFormation, and so on. Especially when you talk about low infrastructure configuration or identity access management, things doesn't happen as you expect, and very hard to maintain. If you don't have the tools to be able to do the tests to ensure that everything goes as expected, well, it can be a nightmare because you never know exactly what was the configuration before. Why do you think that this is happening? I give you one hint. How many of you have access to change the configuration in a cloud environment? Okay. Each of you could change manually a configuration through a PowerShell, through Azure Portal, or through AWS Console that would not be managed in the landing zone creation. This would create automatically a fragile environment that would be hard to maintain, because if somebody deletes it or doesn't know about this change, it will be pretty hard to fix. Where we are now, because it's very important to understand the current status. I was impressed to find out statistically that the current market of infrastructure as code, from the tooling point of view, it's $700 million only this year, and is expected to double in 5 years' time. It might not sound too much, but it's just about a small piece of the full end-to-end story when we build a cloud or an on-prem application on top of Kubernetes. Around 90% of the corporation store at least some data inside the cloud, and around 60% of them have all corporate data already there. That's huge, and this is why we need to understand the impact, to be able to recreate, to be able to test from the scratch all these environments. I was doing some calculation a few months ago when Terraform announced that they are not anymore open source. And you need to pay for the commercial one to understand a little bit about the impact. And what was the outcome? The average number of different instances that the cloud solution has is around 1,000 instances. This number is very, very important. It means that when you're creating infrastructure as code, the scripts that are creating the production environment, the pre-production environment, development environment, would need to manage automatically the creation, the configuration of that 1,000 instances. And we are not talking about computation and storage. Can be policies, it's networking, firewall, identity access management, you name it, everything is there. But you're talking about 1,000 instances as an average, and that's huge. We have the tools to be able to create them, but we are not yet at that moment in time when we have the maturity from cloud infrastructure to say that we are testing everything, and how we are testing it. When you test your infrastructure as code, where do you test it? You are deploying into cloud, right? It might be AWS, might be Google Cloud, might be Azure, and they are checking that everything was created and configured as well. Do you have tests? How many of you have tests that are testing that the infrastructure as code is creating the right resource? I don't see any kind of hands raised. So we would say that we are in the phase that we used to be on application testing around 13 years ago, when everything was done manually. And from time to time, you would hear about Netflix or Twitter, X, and so on, that would say, oh, we are doing automatical testing, but nothing more than test. Nothing more than that. So my main purpose for today is to cover the tools that help us to do that testing, and also to understand what is the impact, how we can do it. Because testing your scripts by doing a full deployment in different environments. It's not cost efficient, it's not time efficient, and you might forget about different things. A few words about myself. My journey on Azure, on cloud, and more exactly on Azure, started on 2010. I did my first commercial project on AWS was on 2016. And I would say that in the last 5 years, everything that I'm doing is cloud related. I'm also a big fan of home automation systems, from physical hardware to the software and so on. And I'm a big coffee lover. I used to drink, I think, 6-9 coffees per day. Now I reduce around 2 or 3. And I like a lot to play with different appliances. Like manual press, V60, and so on. Now, let's coming back. And before talking about it as code, let's talk about the landing zone, because it's very important to understand what is a landing zone, a cloud landing zone. And basically, it's a pre-configured, scalable, secure environment that plays the role of a starting point, that give you the core infrastructure, the core configuration of your cloud infrastructure, on top of which you can deploy the applications, the systems that you have there. It's very important, especially for larger organizations, because if you think about having 100, 200 applications that are running on top of a cloud vendor, means that you need to have different landing zones, one layer on top of another, that are providing that organization structure that is required. Managing everything from scratch can be a pretty challenging part. Why landing zone it is important? You see accelerated adoption, security, compliance, scalability, and operational efficiency. I just give you an example that I want to highlight, is security. Having a landing zone ensure that access management of the technical team, of the IT, to that cloud infrastructure is fully managed in the way that the organization wants. Maybe not having full access, maybe just have temporary access. Maybe nobody can access the backups, only in read-only mode. Nobody can touch the databases, even if the database will blow up, you are not allowed to be able to access them, to see the real data, and so on. Now, one concern of having this infrastructure as code, having these scripts that are building the landscape and so on, is that once the scripts are growing, once the landing zone is becoming more and more complex, you have different concerns that you might forget or not to be able to keep up to date. It's very common to hear about misconfigurations. Well, you usually create, let's say, a Kubernetes cluster. On the documentation, it should have all the time in production 21 nodes, and you end up in one day to have only 5 nodes, and you don't know that why you have quality issues with the service. Why this happened? Behind the scenes, somebody done changing the configuration, and nobody was able to check this. Also, through this kind of configuration, you have secure communication and so on. How you are testing that all the systems that you are spinning up in the cloud are following this? Yes, you have that system like AWS Tower, like Microsoft Defender, that are doing the full scanning of your environment. But from the scripts point of view, do you have the tool that can identify this before doing deployment? That's the biggest challenge. Usually, and I'm saying usually, a landing zone has 6 very important items: identity and access management, security and compliance policies, the networking layer, resource organization, automation and DevOps, and monitoring and logging. What is the biggest benefit is that you can take the application team, you are providing them that landing zone or that standard landing zone, and you say, okay, the computation is done, let's say, on top of Lambda or on top of function, on top of specific Kubernetes service. You have S3 and and RDS as storage, and from that on they can do their business at the application layer without thinking about, okay, how I need to do the networking configuration, how I'm doing the monitoring and the logging at infrastructure layer, and so on. So this is what a cloud landing zone is providing to us. How we are testing this? That's the biggest question. And why it is very important is I've done a calculation, the same average, and I identified that usually a landing zone has more than 250 different files, and with an average of 100 lines of code per line. So this means that we could summarize that we have around 20,000 lines of code, and I'm not referring here to comments. I skipped them. It's just code that is generating the infrastructure. How you are testing this? How many people can do a review? And why this is very important is that in most of the cases, the setup of a team that is building a cloud application, in best cases, looks something like you have, let's say, 3 or 4 developers, 1 or 2 testers, Scrum Master, PM, and maybe you have 1 cloud infrastructure person and 1 DevOps. Or you have a combination between these 2 heads. So saying that somebody else will review that 20,000 lines of code might, but who? Or maybe that person is on another project or on another stream, and if we just take a look on high level, but we don't understand the context. On the other side, you might end up with organizations that have a strong cloud governance team, a center of excellence, where things might look much better, but the reality that is they are relying fully on that standard landing zone, and they will not accept any kind of changes. Why? Because they want to have that full control of everything that is happening at the cloud infrastructure layer. And this is the questions that are popping up. Do you test it? How do you test it? Do you do manual testing, automatical testing? And if you say manual testing, I would challenge you. Do you have a script to do the manual testing? Do you have a document or a flow that says, I test A, B, C, and D, and I'm doing the check that the number of instances or that configuration is configured in such a way? Because that is manual testing in the end. You have a script, you have a clear thing that you need to check, and you are doing step by step. And now, once you are doing the deployment through the scripts, you are asking yourself, did the template deploy successfully? Do I have access control and configuration aligned with what I expected? Are resources correctly mapped and they have the right reference, the right tagging, naming, and so on? Do I still have that monitoring and logging configured in such a way that is required by the application and by the organization? And that's pretty interesting, this part. And why? Because a few years ago, I was on a project with very strict audit mechanism. On the paper, everything looks great. After a few months, there was an incident from the database point of view, and we had to check in the audit. What we found out that the audit information was configured in such a way at application layer that in the storages from the cloud, it would be automatically removed in 30 days. Why? That is the default configuration of that service that was used. Even if the documentation specified 12 months. Why this happened? Because nobody checked. Why nobody checked? Because we didn't have a manual testing script, not even say about our automatical testing. Maybe in a pre-production environment, a long time ago, somebody done the right configuration, changing that duration of the storage. But after a while, it was lost. Why? It's not important. But you don't have the tools. You are able to do these checks. When you talk about infrastructure as code testing, I want to highlight here the I would say the three most important levels. Now, depending on, let's say, what kind of book or from what kind of school you will read books, articles, and so on, there are different perspectives. But I find these three the most relevant one. It is the basic one that most of us we are already doing, is the template validation. Basically, we ensure that JSON, that script that we are writing, is written in the right way. You will not have any kind of compilation error, running error, let's say in this way. You have the second layer, the second level. When you are doing this comparison with a framework, can be AWS Web Architecture Framework, can be the one from Microsoft Azure, and so on. But basically, there are some rules that the cloud vendor is providing, or from standard Kubernetes policies that you are checking. And if you are deciding to use all that rules, you will have warnings, error, and so on. And the third one is the advanced level, where you are validating your scripts, your infrastructure as code, against the organization standards, where the organization can have very clear standards, how you are configuring the networking, how you do the communication, what type of resources you are allowed, where they are allowed to be created, and so on. All these kind of things. You will say, yeah, Radu, we have, for example, Azure policies that we can configure at Azure organization layer level, and it will not allow me to be able to do a deployment in a location that is not accessible by the organization. Yet, that's 100% true. At the same time, that kind of checks can be done on your machine or in the pipeline when you're checking the infrastructure as code. You don't need to reach that moment in time. Basically, we'll talk later on. You need to do that checks, that gates, as shift left as much as possible. You don't need to wait that error to pop up in the last moment. Today we'll talk about PS rule. That is an engine, a framework that is allowing to do this. But also we will see that there are other tools, and you will find tools specific for Terraform that are allowing you to do this. Tools specific for each, I would say for each CI/CD tool, because you will see that there are different flavors and so on. So what is PS rule? It is basically a cross-platform module to validate the infrastructure as code objects that you are creating through ARM through ARM, for example, through PowerShell, and basically through the Azure tools. The same thing that we will talk today are applicable for AWS, are applicable for Google Cloud, but using a different system. Now, how you do the installation? I would say the first step. It's pretty simple. You need to install the AZ model and the AZ resources. If you want to be at the third layer, meaning the advanced one, then you need also to install the enterprise policies as code. And we'll see later on why this is very important and is very, very useful. So from the configuration, you just put some packages. It's not too much. Now, when you do the configuration, you need to have a PS rule YAML file. And you are specifying in which kind of source file you are using. In this case, we will use in the example Azure VCHEPs. And also you can decide if you want to have warnings and a lot of configuration there, step by step. It's very easy to use, and as we can see, for example, let's take as an example this one. Can you see it, or it's a little bit blurry? Let's give it a try in a different way. Let me zoom in. Now should be better. It's just a simple BitChef file that what is creating some storage account and is specifying exactly what are the storage accounts what are the location for the storage account that you are allowed to create. Nothing more than that. Now, basically, this is the input of the example. And the challenge here, or the question would be how you can test this. Yes, we have the manual test, as we talked before, if you have the flow, or you can do the scanning of the template with the PS rule. For example, the most simple example here is to do the summary one. And basically, it will scan the files and will check exactly through the. Let me just do a step back. We are at this phase now. This is what the PS rule allows us to do, to validate our code, our infrastructure code, over the well-architectured framework that Azure is providing. We can decide exactly what we want to check, what we cannot check, and what we should like to ignore. For example, if you are using tags, if you do replication of storage, and basically each service comes with a list of rules. There are around 300, 400 default rules. You can identify exactly the one that you want to keep, the one that you want to ignore. And I expect that you don't want to keep all of them, but most of them you might want to be aware of. And you have an outcome that you can use later on to have a build fail or to notify team and so on. But what we don't have here, we don't have the details why this happened. Because if you provide something like this to a cloud infrastructure person or to DevOps or to a developer that is doing also this part, will say, okay, use text, but what does this mean? What is the main purpose? Now, if you want a detailed scan, you don't need the summary one. It's pretty easy to get. And what you obtain, let's see if we can do a zoom. 1 second. Yep. And what you get here, it is basically what failed, and also a list of recommendation. Why it failed, and more details about that. And also if you look, you'll find more information, why it makes sense and now. And this is a very good moment in time, especially in the initial sprints, to decide what you want to keep and what you want to skip. Because you might realize, okay, that from that 50 rules that you have for Azure storage, you care or are relevant for your system only a few of them, maybe 10 or 5, and I will keep only these ones. Now, how you do this? You can do this with rule suppression. Suppression that is available in 2 different approaches. One is to exclude. Automatically, you specify exactly what are the rules that you want to fully ignore them. You don't care about them. You might say, okay, I don't care about tagging, or I don't care about having replication on Azure storage, and that's perfectly fine. What else you can do? You can do suppression, meaning that for specific instances, you want to ignore that. Maybe, for example, for non-development, non-production, pre-production environment, and maybe for some testing environment, you don't want to have active the archive functionality. But for production, you want to have it. So you can use suppression exactly for these kind of things, and also the naming can be automatically generated depending on what you do. Now, the challenge here is when you have policies, because defining policies in PS rule, you can do it. I'm not saying that you cannot do it, but it's not so nice. There's a lot of JSON file that you need to modify, you need to keep up to date, and so on. It's not very, I would say it's not very friendly. And if you have 50 or 100 rules that you need to modify, you need to maintain, can be pretty hard. And another challenge here, that we'll talk a little bit later, is not about maintaining them. It's about if the organization decide to change a policy at the organization level, you need to do at least 2 changes now. One, is in the cloud vendor configuration, the organization level. And the second one is here for PS rule to ensure that the configuration was updated and would reflect the reality. Meaning that you need to have a procedure. What we know about procedures, how often they are followed. Most of the cases, except one time, when things will go wrong. Exactly that one time when somebody will forget to do that update, you will end up in a situation when something is forgotten. Exactly the example that I gave to you at the beginning with the audit configuration from 1 month to 12 months. Now, when you have these policies configured, when you are running the PS rule on top of your template, you will receive very nice messages that will say, okay, this is the policy that you define and is not followed. You can have exactly what is the message, what is the URL. You can even have, for example, if you have custom one for the organization, you should contact, let's say, cybersecurity team, or you should contact the enterprise architect team, or I don't know who from the team or from the company that can provide support or can decide, okay, this can be exception or not. Also for tagging, a very common problem that I saw is that at the organization level, tagging is mandatory. You need to have specific tags to be able to identify the department, the cost center, and so on. These are enforced when you do the deployment, and you're receiving errors if you don't configure them right when you are doing the deployment. Now, another thing that PS rule is allowing us to do is if you're integrated it in a full CI/CD pipeline, PS rule can provide you an output in any unit-free format. And this is very, very important. Why? Because you can create on top of it, because, for example, Azure DevOps and most of the CI/CD systems are able to crunch this format and to provide a nice user interface on top of which people can understand what happened, to drill down, and so on. This is where PS rule is very well integrated with the different systems. Doing a step back, I was saying that the policies themselves are nice, but are not very easy to maintain. To define them can be pretty simple. Now, PS rule comes with another feature. Export AZ policy resources, the one that I was saying a little bit before, combined with a small converter, if we can say in this way. Basically, with these two steps, you can take the policies that were defined in Azure at the organization level for a specific subscription, and will inherit all the policies. You can export them locally, and you can transform them in a PS rule format, meaning that you could have a full automated system that each time when an Azure policy is modified, also to update the repo where the policies are stored. So you would ensure that if somebody is doing a change in the Azure policies, this will also reflect when you are doing the checks on the local systems. A small hint here, you can have triggers. You can automatically trigger this when a policy is changed. So you have the hooks also in Azure, in the CLI, to be able to do that. That would have a function. The Azure function would trigger that pipeline that you are defining in different ways, or even in the Azure function, do automatically export, conversion, and would store in the right location. Now, I was saying about the benefits of using such a tool. First of all, you do a shift left. You identify issues in the configuration, and you can provide very fast feedback. in an early stages. You don't need to wait until the end of the sprint or until you finish the old script that you are working on to be able to identify that something is not configured in the right way. Also, you can have so-called quality gates in the pipeline that would ensure the same thing, that the code that you are working on to be able to build that landing zone, to be able to build that infrastructure, is done as expected. And you also can do continuous monitoring on the configuration and on all these kind of things. And what can be done on long term, because nowadays cloud is a commodity, is the following. The organization might decide that in 1 year time, nobody, let's say, will use anymore databases that don't have backups configured for 3 months on AWS. It means that you need to have the backup configured and some scripts that would do these kind of things. Through such a tool, you can push to all the teams that are using that kind of services, basically the data services, to get during 9 months a warning that when they are doing the build and the checking, warning, please consider that starting from January 2024, you are not allowed to do or to have this kind of configuration, and from the 1st of January, you can automatically trigger the build fail for this part. And you wouldn't allow them to do the next step to push to the cloud. So you can have also a long-term vision and long-term governance of it. So what other tools are on the market? I wanted to mention some of that are available on Terraform, because I know that a lot of people are using Terraform. How many of you are using Terraform, or your teams are using Terraform? 10%? To tell you the truth, I expected more. I saw there's a trend usually on the market that people usually know Terraform plus a specific cloud vendor as code, like ARM or like CloudFormation. So some tools that I wanted to mention are EFTeam and Validate for syntax and for format. We have planned to do the configuration to be as expected. We have TF link that is able to do the syntax verification, the structure, and also to do the account limit. The account limit, what does it mean? That you can specify, you can have a policies like in PS rule that you specify the maximum number of instances that can be created of VMs of EC2 machines are 12. And if a configuration is over 12, then automatically it will throw an error or a warning depending on how you configured. And we have the Kitchen Terraform and TerraTest that can do that automatical test to validate and to run the sandbox. The thing that is doing on the PS rule, what I want here to mention is that these ones would do the deployment in a real environment and would do some checks. So there are different approaches for the same outcome. Now, what are the conclusions or the things that I would like to highlight? And it's a very simple one. If you're working on a system that is using cloud, or you are using Kubernetes on-prem, and you have any kind of scripts that are doing automatical creation of environment, because not everybody might use the standard one, you might use some specific one, or okay, I have inherited the old PowerShell ones from the previous team. That's perfectly fine, but identify a tool, a testing tool for your infrastructure as code that would allow you to do these tests. Don't expect that starting in 1 week you would have everything, but do that small steps, one step by a time. Maybe just to verify that the name validation is done correctly, or you have tagging, or the location where they are allowed to create resources are specified and so on. And one by one, to add the ones that are the most important, the ones that are adding business value to the business. Because if you can identify that one or two small things where the business, where the stakeholders can see value, would enable you to have support from them to implement fully these kind of things. And I would just give you an example here. It's not about testing of each other's code. It's about having the ability to create it from scratch an environment. We are talking about a team or a set of multiple teams, around 30, 35 people. All are developers in Python, are working on a system that is running on top of cloud, on top of AWS. They are happy with the current system. It is a legacy system that was migrated through a lift and shift manually. And the recreation of an environment usually takes around 1 day. You say, oh, 1 day it's a lot. Well, yes, but statistically, they need to recreate their development environments only one time every 3 or 4 months. It's not a big deal. But when you go to the customer and you say, okay, through a 50 days investment, you can reduce the creation time for 1 day to 1 or 2, let's say to 2 hours. And statistically, in 1 year, 80%, 80 days are lost by the development team waiting and recreating the environments, the development environments. He said, okay, I don't want for production because it's very stable, and they consider they have very strong procedures that are done manually. But for development environment, we want this. That was the first step. At this, you have happier developers. What is the next step? Once he's seen this value, he might go for the production one. Because once you have for development, that is that usually development and the production one are very, very similar at the application layer. We don't go at the cloud networking layer where you come with the organization policies that might be more and more complex. So start on small steps, the thing that you see very valuable to the business and bring value, and that would help you in the end to make your day-to-day work much, much easy. Thank you.